Okay, ladies and gentlemen, part two, we're going to do our speed time graph. So that's the right side of our foldable here. So we're going to be starting here. Okay, so let's get going. Okay, remember what I said about the distance time graph. It's the same thing for speed time graph. The most important axis is the y. So notice how this one says speed. So on the front of your foldable, it says the speed time graph shows us how the speed of a moving object changes over time. Okay, so we're measuring the actual speed, or how fast the actual object itself is going. So if we look at this example here, again, my origin is going to be some type of starting point. So the starting point should always be 0, okay? And then your highest speed, let's say it's 100 something, okay, is here. So over time, this object went from 0 to 100. So what would that mean? If the speed is increasing, if you said it's accelerating, you're right. And since it's speeding up, what type of acceleration is it? Well, it's positive. Speeding up. Okay, let's move to the inside of our foldable. A straight line or a steep angle, a straight line pointing up on a speed time graph means there is an acceleration. The speed is increasing. So down here, I have speed of 0. Up here, speed of 25. And speed is what I'm measuring. So I am accelerating again. This is positive acceleration. And this is how we will abbreviate it on our brain dumps. Okay, so now our horizontal straight line means that the motion of the object is constant, because now we're measuring actually how fast the object is moving. So it means the object is constant. It does not mean that it's at rest. Okay, so I circle what's my y, which is speed. Okay, and I look at where my line is. My line is staying here at 10. So if this is speed is being measured in meters per second, my object is continuously going 10 meters per second. It's 10 meters per second at 2 seconds, at 4, at 6, 8, 10, all the way to 22. So it is maintaining its speed. So a straight horizontal line in this case is going to be a constant speed. So it's kind of like cruise control on your car. Okay, what if I had a line that looks like this? Okay, speed time graph again. Well, if the greatest speed is up here and the speed of 0 is down here, then you might have guessed it, you are actually slowing down. So it could be getting off the freeway. When you exit the freeway, you have to slow down because the freeway has the highest speeds. So this car is slowing down, or this object is slowing down to 0. So that is negative acceleration. Okay, so a straight line pointing down on a speed time graph means there is an acceleration, the speed is decreasing, or I have negative acceleration. So now you should be around here or here. So let's break this down. So again, I have a speed time graph. I have a speed of 0, and I can pretend this is a speed of 100. Okay, so what's my object doing? This is all one line with continuous segments. Okay, so from here to here, my speed, is it increasing or decreasing? I'm moving closer toward 100, so I am increasing. This is positive acceleration. Okay, then here, what am I doing? If you said at rest, you better smack your hand, because that's not it. Okay, remember, we're talking about how fast it's moving. So clearly I'm at a speed other than 0 here. Okay, so I'm at a constant speed. Constant speed there. Okay, then here, what did I do? I sped up just a little bit. So that's going to be a positive acceleration there. And then here, what did I do? I slowed down all the way back to 0, so that's negative acceleration. So this is kind of what you should have. I have steady acceleration, a steady speed or constant speed, a gradual acceleration because I didn't accelerate a whole lot when I got to this point here. Okay, now remember, this is not a word. What do we say instead of deceleration? We say negative acceleration. And that's part 2 of your types of graphs.